GNSS RNS integration. We will use the gAirhawk software to process the laser point calculation to get the point cloud. We still use the projector to organize the data. We create a new project in the lead file, lead directory. We set as test. Okay, we add the lead 3 files and port file. The port file use get the result of the GNSS RNS integration. We use RNS txt. Okay. Here there will be 3 files, and also we can get integration of the point calculation. The device type, echo type, device type. In this case, we use the whole site. Also support the GeoTXT, Veladai, Lego, Libox, SealStar, Nathan, Robsense, and etc. And we use we can set the coordinate system. This system is for the ports. That means for the irns.txt file. In that file, we use ENU. Also, for some other software, for example, Podback, they use the coordinate of NED. And for the turning and remove turning radius, set as 20 minutes. If we want to remove or cut the turning point, we'll have a check. If we don't want to remove the turning, just keep it black. And for the revolving angle from the lidar, we found have a look of this file. Okay, here we found the revolving angle 90 degree, 0 and minus 90 degree. The same here. And also from the left arm from the lidar to approximate body frame 0 minus 005 minus 059 minus 0.028, same here. And this calibration angle from the body frame to the approximate body frame of MU. Typically this value will be provided by our engineer, and this angle is different for every unit. We will get this value for every unit during the sale. The X is 0.12, 0.1, 0.2. Okay, so here, same. And for the coordinate, we use Wuhan. Wuhan coordinate system is expressed in our coordinate system. Here we call Wuhan, have a check of the Wuhan, and for the episode we found that we use transverse Mercator projection, and this central membrane. This original latitude, and for the eastern, typically we set at 500 kilometer. Same here, 500 kilometer. And for the fourth northern, typically we set at 0. That means from the calculation of the equal. And scale factor we set at 1. And don't use the zone number. Okay. And this for the transformation parameters for the destinate coordinate system. Typically we use the Hermet or Modinsky and Wolf. In the Modinsky, we have the 4 parameters, and this is for the knowledge about the coordinate transformation. Okay. And for the coordinate format, we have the 4 options. First one is BRH, that means latitude, longitude, and height in degree unit. This is DMS unit, and also we provide the XYZ in ECF flare. Finally, is ENH, that means after the projection. Here we select ENH. Okay. After the configuration, we can calculate the point cloud. Okay. First, we read the pose file and get the first lead file and get some. Okay, here. How we found the maneuver of the aircraft. During this time, the aircraft should be on the land, and here move directly and to change the direction. Okay, it's here. Let me this running on air, and have a turning. Okay, let's move into the flight, to the flight line. Yes, typically there will be take several minutes according to the flight time, according to the dead size. Okay, we have a rest. Let it to calculate, and also we can have a look some notice of the improvement of the accuracy of the point clouds. These are 4 instructions for improvement. First is to control the flight height. As we know, the accuracy of the point cloud have the relationship of the pulse accuracy, and based on a certain pulse system, we wish to control the flight height if the height is too high, no, if the flight is too high, the accuracy will be poor. Typically for our GS100, we hope the user to keep the height about 70 to 80 meters, and to the 100H, we hope they keep the same height, and to the 260S, we hope they keep the height about 150 meters. In this way, the accuracy will be good. And second key point is to keep the flight speed. Typically, we hope the flight speed should be not less than 10 meters per second. Because for the process time, the speed will influence the accuracy. The higher of the velocity, the better of the accuracy. But as we know, we could not to keep the velocity higher and higher, because in this way the density of the point will be poor. Actually, this is the balance of the accuracy and the density. And third one is to set the FOV less than typically 60 degrees, because at the side of the flight, the accuracy of the points will be less than points in the center. And the last one is to guarantee the land is dry, because the water on the land or in the surface of the objects will have influence of the reflect strength of the laser scanner points. So we hope the user have attention of the ultimate and to let the land is dry during the flight. Okay, we found that. Okay, we get the result of the point cloud. Here we found the cloud points of the several flight lines, and this is for 3 file, and we can have a check or not check of the flight. Here, this is second file. This is third file, and show the different lines. Okay, and also we can find that there will be 3 files of the result. pc.txt, everyone relevant to the lead file. These 3 are the result file. And after the calculation, we also can to output the last file. As you know, the last file is the standard files of the laser scanner system. also after this is still this is calculated. After the output data file, there will be an instruction, indication of the file, indication of the output. Here, we already found that this data file, a second data file, and will be the last. Okay, second one. This is the first one, second one. Because second file of the point cloud is really big, so it will be cost several seconds. Okay. Still not finished. Be patient. Okay. Second last file is finished. It's created, right? And this right now is output of the third last file. Also, this one will be cost several minutes. 1 minute or 2 minutes. And this last file can be input to the software of the post processing. For example, Solid, Catalyst, and other softwares. Okay. This is the tip of the last file conversion finished, and we have a look of these three files. First one, second one, last one. Okay, and after the output of the last file, we already finished the calculation of the point clouds, and we can close the gAirhawk software. And actually, if we want to have a look of the point clouds later, we also can use the gAirhawk to open the project. For example, we can open the test file, test project, this zip file we established just now. We also can open it. Okay. Still, we can find that these three files, and to get the result of the point cloud txt file, and also we can get the last file again.